Hi math friends, today we're looking at an introduction to negative numbers. So let's look at what a definition of negative numbers first. Negative numbers are numbers that are less than 0. So they can be whole numbers, they can be fractions, you can have decimals. As long as they're less than 0, they're negative numbers. What uses do they have? We'll see some examples here too. Generally, when we think of like debt, if you owe money. When we think of temperature, we see negative temperatures in the forecast sometimes. And if we think of like the passage of time. So we'll look at a couple of those, and hopefully that'll help us start learning how to use them. So let's look at a number line. Simply put, if we just count straightforward here, if 0 is in the middle, that's already marked. If we count by ones like we know how to count, 1, 2, 3, and so on, we could number this as far as it goes. And remember, the arrows on the end mean that they would extend into infinity, or they would extend forever. One concept here is that I'm going in the positive direction, so the infinity over here would be the positive version of infinity. So what happens if we go to the left of 0, or if we go under 0? So I'm going to kind of like have a mirrored image here. Less than 0, I'd have negative 1. If I have 2 spaces less than 0, that's negative 2. 3 spaces less would be negative 3. And I put a minus sign in front of the numbers to show this. These numbers are getting kind of scrunched up here, so I'm going to put negative 4 here, negative 5, and so on. With that negative sign, we really don't have a lot of room to write these here. Negative 7, negative 8, negative 9, negative 10. And remember, the arrow shows that this could go on forever. So this is going to go through negative infinity. So look at how these are opposites of each other here. All right, so we can count 1, 2, 3, 4, or if we go negative, we go negative 1, negative 2, negative 3. Some concepts that are hard to grasp are that like negative 1 is a bigger number than negative 9 because it's closer to positive infinity than negative 9 is. All right, let's look at a couple more examples here. If we skip count, so skip counting, like if we count by 2s, we count 2, 4, 6, 8, and so on. If we count by 5s, we go 5, 10, 15, 20. We count just the multiples there. So we can do the same thing with positive and negative numbers too. So if we start at 0, if I want to count by 5s, I'll go 5, 10, 15, and remember, I'm just writing these here because it gives us space. 20, 25, and so on. We'll just do the first few here, and then we'll reset this to see some more. If we go negative and we count by 5s going in the negative direction, we get the same idea, but we get that mirrored image. So when I go to the left here, after 0, I'm going to have negative 5, then negative 10, then negative 15, then negative 20. So we're still counting by 5s, but we're just counting down and going negative here. Okay, so the concept of negatives can be kind of tricky because it seems like we're going up because we're going 5, 10, 15, 20, 25, but they're negative, so we're actually getting lower numbers. Okay, one great way to think about this is money. Like if I have $5, it's positive. If I borrowed $5 and I need to pay somebody back, that would be a negative $5. So I'd want to stay in the positive when I think about money there. We'll explore more of this too. This was just an introduction to negative numbers.